Hello everyone and welcome to my channel. In this video we're going to learn about the repository pattern. Repository is one of the most useful patterns in software. It helps you encapsulate data access so that you can hide the implementation details and the complexities of interacting with your data sources from the business layer. Before we get started, I would like to ask you to subscribe to my YouTube channel. It's a small action, but it goes a long way to supporting me to continue making this content. Now we've got a lot to do, so let's get started. So I've prepared a repository for this tutorial, and the reason for this is because we need some starter code before we can start working on the repository pattern. I want to focus the video on the repository pattern, so I don't want us to spend time working on the database models and things like that. All of that is already done in this starter code. So what I would like you to do is go ahead to GitHub to this repository. I'll put the URL in the description of this video, and just go ahead here and clone the repo into your computer. And then what I would like you to do is check out into the tag named start. So you do it this way: git checkout start. So start is a tag that I've created to position the code in the stage where we need to start working on the repository pattern. So what does the code look like at this point? We have an API implemented with FastAPI. It could be any other framework. The repository pattern is useful regardless of the framework and the technology that you use. The point of repository is to help you encapsulate data access. So in whichever situation in which you're dealing with databases or any other sources of data, and this includes in-memory databases, it includes even APIs. So whichever type of technology you're using to persist data, repository is a good choice of pattern to encapsulate those operations. So we have a simple API here. It contains two endpoints. It's kind of replicating the functionality that we would have to make bookings with restaurants. So we have an endpoint that allows us to get the list of bookings, and we have another endpoint that allows us to place a booking with a restaurant. And then we have a very simple database model here implemented with SQLAlchemy, and we already have the migration as well. So what we're going to do before we start working is we're going to run the migration to have the database set up. We're going to test the API to see a little bit how it works, and then we're going to start working on the repository pattern, and we're going to refactor the APIs to decouple it from the database access layer. So we have one model only, which is for bookings. If this was a proper bookings application, we would have a lot more models, a lot more endpoints. But this is just a simple API just to illustrate how repository works. So I'm trying to keep it nice and simple so that we can focus on the repository and the way it works. What happens in the API here? So what happens here is the API layer is tightly coupled with the database. If you see here, we are directly creating our connection with the database. We are obtaining our session factory object, which we use in the API views here to open a session with the database, and we are performing database transactions directly under the API views. This is very common in many code bases. I work with many different clients every year. I review their code bases, and this is one of the most common patterns I find in their software. We are performing database transactions directly under the API layer or directly in the business layer. The problem with this approach is that we are tightly coupling layers. We are tightly coupling, in this case, the API layer to the database layer, or in other cases, we're tightly coupling the business layer to the database layer. The problem with this is that if we make any changes to the database, could be we change the database system, or not even that, maybe we just rename some tables, or we change some indexes, or we change the relationships between some tables. These are normal changes to any database system. The problem with when that happens is we run the risk of breaking our API layer because we have queries spread all over the code. And when we make any of those changes, we have to go carefully through all of the API views and any other places where we are performing transactions with the database and make sure they are updated correctly to reflect the new database design. What repository does is it puts all the database logic in one place, and that's the repository. The repository contains all the logic necessary to perform transactions with the database, including queries, updates, writes, deletes. Everything goes into the repository, and our business layer or the API layer consumes that code, and this code the repository exposes is just a technology agnostic interface. So if you're using a SQL database and tomorrow we switch to a NoSQL database, the business layer won't care about that because it's consuming a technology agnostic interface, which is the repository. The repository is typically implemented as a class, or it could be a function, and it just requires normal parameters for filtering data or for writing this data to the database. The code which is consuming the repository doesn't know anything about what's happening with that data, and it doesn't care because it doesn't have to. All it knows is that this data is being saved somewhere, or it's being updated, or it's going to be retrieved from some source, but it doesn't need to know how that happens. The repository takes care of that. So how is that helpful? Well, it helps us, first of all, it helps us decouple the layers of our application. So when we're using the repository, we encapsulate data access in one place, and this helps us test our layers in isolation. So once data access is encapsulated in one place, we can test with the business layer in isolation of the database. It also helps us create reusable code for our database operations. So once we have a function or method that performs a specific query with the database, we just reuse this function everywhere else in the code. And finally, it makes it easier to make changes to the database. If something changes, the way we have to make a query, we only need to change that function that is taking care of this query. Or if we change the way we have to delete records from the database, that function or method which is taking care of that is the only one thing that we need to change. So repository is really one of those simple patterns that bring a lot of benefits to our code. It makes the code more readable, maintainable, and easier to manage. So to get started, let's see how we implement the repository pattern. So the first thing we're going to do is we're going to create a file named bookings repository, which is going to contain the implementation of the repository for the bookings table. So let's do that. Right. So we have the file. Now let's implement the repository here. How do we implement a repository? There are different ways of doing this. The most widespread implementation of repository is that the idea is that a repository offers an in-memory list interface to the code. So when the code is consuming the repository, adding and deleting elements from the database looks like adding and deleting elements from a list. It doesn't necessarily have to be that way, but that's the most canonical or widespread implementation of the repository. It's usually implemented as a class that exposes basic CRUD methods. So a get method to get the data, an add method to add data to the list, which is actually a database behind the scenes, and so on and so on. But really, the point of the repository pattern is to encapsulate data management logic. And if there is a situation where you only need one function to encapsulate some specific database logic, I would say that's fine. I like to be pragmatic in this sense. I don't like to implement patterns for the sake of the pattern, and in some cases just one function maybe is sufficient. The only thing I would recommend you is to always parameterize the database session, because the repository pattern is not supposed to perform commits of your transactions to the database. This is to allow the consumer code to put together as many repositories as necessary to perform the transactions and commit them or roll them back depending on the situation. So let's go ahead and implement this bookings repository now. We're going to parameterize the database session, because again, the part of the code that controls the transactions is the consumer code, is not the repository itself. Now let's add the basic methods that repositories usually have. So the first of them is a get method that allows you to retrieve one element from the database. We typically have some data filters. Typically, we also have a list method that allows us to get a collection of records, again with filters as well. We also have an add method, and what we're going to do is we are going to declare the parameters of the booking. We're going to look at them in a moment. We also have usually an update method. And we also have a delete method, which in this case is usually the ID of the record we want to delete. It could be anything else, depending on your depending on the nature of your data. So this is the most basic and classic and widespread implementation of a repository. Now what we are going to do is we are going to move the database logic from the API layer into this repository. So to get a list of bookings, we do this. So let's move that here, and we return the result of this query. Let's import the model here. We're not going to need any filters in this case, so we're just going to remove that. And to create a booking, we do it this way. So let's copy that into the repository. And what we're going to do here is we're going to declare explicitly the parameters that we need to create the booking. So we need restaurant, we need date time, and we need party size. So let's remove those things. And self session add, and then we return the booking object. So these are really the only two methods we need in this API. Obviously, if we had a full implemented API, we would have to implement the rest of the repository methods. But just for illustration, we're just going to focus on these two and see how this helps us to decouple the API layer from the data access layer. Now, what we need to do is remove these database transactions and instead call the repository here to perform our operations. So we do it this way. We say bookings repo equals bookings repository. We import it, and we pass the session, which is the required parameter, and then we say bookings equals bookings repo list, and that's it. And then here, what we're going to say is we're going to instantiate the bookings repository first, like before, and then we're going to say bookings repo add. Actually, we're going to copy the parameters directly here. The restaurant, date time, and party size, and that's all it takes. So we've taken the first step at decoupling the database access layer from the API layer. Let's run the server and let's make sure everything's working well. We're going to create the virtual environment first. So we're going to say ppenv Python 3.10. Then we're going to say ppenv install dev. And now we're going to say ppenv shell and ubiquon run server reload. Okay, so the server is started. Let's do some queries here. We're going to the localhost 8000 documentation, and it's failing, and that's because we haven't passed the database URL, and as a matter of fact we haven't even run the migration. So let's do that first. We have a migration here already under the migrations, under the versions. We have this migration which is just going to create the booking table on the database. So let's do alembic upgrade heads. The database is already created. It's right here under database.db, and what we're gonna do now is we're gonna run the server again, but we need to say database URL equals SQLite database.db. Okay, let's reload the page. Oh, it's already reloaded, and now we can create records. Let's create a field, and we can retrieve those records from the get endpoints. And so everything is just working fine. Now, the API layer is still tightly coupled to the database layer because we are initiating the session maker here, and we don't want to do that. We want to have the database layer completely clean of database code. So let's get rid of that. And the way we're going to do it is by injecting the session maker as an object of the FastAPI application. So what we want to do is we want to make sure this is instantiated at the point of starting the server. So when we create the FastAPI object, we want to be able to inject different kinds of session makers according to our needs. By the way, what we have here is a very simple test of the server. Because the API layer is taking care of instantiating all the database access, we don't have anything here, but we're gonna change the test also so that the session factory and the repository, all those things are injected through the create server function so that we have control over those objects when we run the server. So if we run the test now, it fails because it needs the database URL. And it passes, but the problematic element here is we are still using the database. So we want to get rid of that. We want to be able to do just pytest.testpy and have the test running. We want to be able to test the API layer without needing a database. So let's continue our refactoring to be able to get to that point. So what we're going to do in the server, here in create server, we are going to require, it's going to be an optional argument, just in case when we're testing, there are some endpoints that don't need access to the database. So we want to be able to test those endpoints without having database access. We're going to have a session maker parameter, which is optional. And we're going to say server session maker equals session maker. Now in the runner file, we are going to get this code, we're going to move it to the runner because here's where we instantiate the server. And we're going to say session maker equals session maker. Okay, now how do we access these objects from the application in the API layer? So you know in Flask you would do something like import current application or current app, something similar. In this case, we can't do that in FastAPI. That's not how it works, but it does have a way to access the application object, and that is through the request object. So what we need to do is to have access to the request here, and we do that by parameterizing the request in our view functions. We need to set this to the right type, which is the request class from Starlet. And then what we do is, let's say, from request app session maker, and that's how we access the application object, through the request. And here we need to add the request as well, so we do this like in the other function view. Now this is looking pretty good. At this point we don't have any direct access to the database in this code. All database access is being parameterized or taken care of by other layers, so we're almost there to be able to test this code without needing a database. Let's run the server first to make sure everything is working correctly still. So we start it again. We come here, we try the get endpoint again, and yes, it's working. So we're getting the list of items without any problem. Now if we test the API, so let's go to the previous test we were running before. If we test it like this with the DB URL, that it's failing at the moment because we haven't updated the test yet. We need to inject the session into the test. So let's do that. So we need to get this and say session maker equals this. And now we can run the test. So the test passes, but like you see here, the problem we have is that we still need a database to be able to run the test. And we don't want to be using a real database. We want to be able to run very quick tests without depending on a real database. So how do we do that? What we want is to be able to pass an object here which is not a real database session. We want to be able to pass a different kind of object. A good candidate here, in the case of Python, is magic mock. So we're going to pass just a simple mock object here. And let's run the code again and see what happens. So we're going to remove the database now. and it's not quite working. And the reason why it isn't working is because we don't have a real database, and therefore the repository is not working with real database sessions. It's not really working as expected. So we still need to do more work to fully decouple the API layer from the database layer. One thing we should notice is that in the API layer here, when we add an item to the database, the bookings repository is actually returning an instance of the booking table. So we create an instance of this SQLAlchemy object, and we return that. That is actually a database object. Our API layer is not fully decoupled from the database yet. To be able to fully decouple both layers, we need to have a bookings object, which is not a database object. It should be a business object. Let's go ahead now and create a business layer for bookings. We are going to do that in a new module. We are going to name it bookings. And we're going to create a booking class within this module, which is going to represent a booking, but as a business object, not as a database object. And what we're going to do is we're going to return that object from the repository so that the business layer doesn't have access to database records anymore. So let's go ahead and see how we do that. So we open bookings, and we're going to create a class here called booking. To initiate it, we need the restaurant ID, which is an integer. We need the party size, which is the number of people who are going to attend the booking. We are going to need the date time, which is the date of the booking. And we're going to need the booking ID. But that's going to be optional, because if you see what happens in this code, we need to be able to obtain an instance of the booking before we commit the transaction. We don't have an ID until we commit the transaction. So the repository won't be able to have this booking ID until we have committed the transaction. So for that reason, the ID is going to be optional. Now, we still need to be able to access the ID here. And this ID is only accessible through the database record. So what we're going to do in bookings is we're going to add one more parameter, which is the booking record, and we're going to set it to none because it's not going to be always required. So if we have a booking ID, we don't need to pass the booking record, but otherwise we need to pass the record. This is the only kind of tight coupling that we're going to have between the business layer and the database layer. We have other ways of accessing the ID. So if we flush the transaction before committing, the database is going to push our transaction into the staging area before committing the transaction, and it's going to generate an ID, a non-reusable ID. But we don't want to do that because otherwise this operation does consume some database computing resources. So we're going to keep the database busy, sometimes for no reason, if we end up having to roll back the whole operation. So to avoid that, we're going to allow retrieving the ID from the booking record when we don't have it yet. And I'm going to show you how we do that. Let's import these elements here so that the code works. And now what we're going to do here is we're going to say self restaurant equals restaurant, self party size equals party size, self date time equals date time, self ID equals booking ID, and self booking record equals booking record. The ID is being assigned to a class property which is declared with the leading underscore, and the reason is because we really want to tell consumers of this class that this ID is not supposed to be accessible this way. We're going to create a property method of this class that is going to resolve the ID dynamically. Again, the same with the booking record. We don't want to allow consumers of the class to access the database record because we would be allowing the consuming code to perform transactions with the database directly through that record. We don't want to allow that, so we are signaling that with the leading underscore. The next thing we want to do here is to create this dynamic property with the property decorator for the ID. And this is going to be, if the ID is available, we return that. Otherwise, we get the ID from the booking record. Simple as that. And finally, we're going to have a dictionary method here that allows us to obtain the dictionary representation of this object. Nice and simple. So this is the ID. Restaurant is the restaurant. party size is the party size, and date time is the date time. So this method is going to be very useful in the API layer to obtain this dictionary representation of the object directly and return it as a payload. Now going back to the repository, what we want to do here is we want to change this naming as booking model because it's a database model. We're going to change these references, and what we are going to do now is we create the database record, we add it to the session, and then we're going to return an instance of the actual booking business object, and we pass the relevant parameters. So this is the restaurant, the date time is the date time, and the booking record is the booking record from here. We don't have the ID yet because we haven't committed the transaction, so we are passing the record so that it can be resolved from that object. The party size is undefined, so we also need to put it here. So party size equals party size. Alright, so the add method is now returning booking business objects, so that's very good. We also need to change this method actually. It's returning a list of database objects at the moment. So we want to change that and return a list of business objects instead. So we're going to do it this way. We're going to say booking, dig for booking in the list of bookings. The database model also has a dictionary method that we added here to make it easier to obtain this representation of the record. So that's the dictionary method we're calling here. Now we've done that, let's go back to the API layer and make the necessary changes to fully decouple the API layer from the database layer. So here we don't need this transformation anymore. We just need to say bookings repo list, and that's it. And now here in the post method, the booking is now the booking object that we just created. So all we need to do here, we just committed the transaction here. So the booking ID is now available. So all we need to do here to return the object is just call the dictionary method, and this converts the object into the payload. So let us test now that this is working fine. Let's restart the server. Let's execute this method. It's working well. Let's test the post method also. P records. We call this again, and yes, no problem. So everything is working correctly. If we do the test again, PyTest is still going to complain. So check this out. And this is because we were using the magic mock in the test, and the magic mock doesn't really work as a database session, so it's not returning booking objects or anything like that. So what we need to change now is the way we access repositories in the API layer. At the moment, the API layer is importing the repository directly. Now this is a repository that is expecting a database session to work correctly, and we could do that. We could mock the database session to replicate the way SQLAlchemy sessions work, but really that's unnecessary, and that's not the point of using repositories. The point of using repositories is that we have a technology agnostic interface that becomes available to the code, and the code doesn't care where this interface is coming from. So what allows us in the tests is to create dummy repositories, and those dummy repositories don't work with databases. They just replicate how the repository and the database are working together, but they don't use a real database, and therefore they allow us to test the layer in isolation of the database layer. So to change this, what we're going to do now is we're going to create a registry of repositories. We do that through the terminal here, and in data access, we're going to create a repositories registry. And in that file, we're going to create a class called repositories registry. The initializer is going to require a list of the repositories that we need to use to create this registry. So we only have one repository at the moment, which is the bookings repo. So we set this parameter here, and we say bookings repo equals bookings repo. Nice and simple. Now what we do is we create this instance of the repositories registry in the runner file. And this is going to pass the bookings repo with the real bookings repository class that we implemented before. Now we want to be able to pass this here in the create server function. So repositories registry equals repositories registry, and we need to parameterize that here. Again, optional in case we have some cases where we don't need them, and then the server repositories equals that. And now what we want to do in the API layer is we want to access those repositories through the request object. So we say request app repositories bookings repo. And this bookings repo is the property we declared here in the registry. Okay, so we do the same here. Instead of this, we say request app repositories bookings repo. We delete this one here, and now we certainly don't have any database code in this layer. Now what we can do in the test is we remove also this database code from here, and we create a dummy bookings repository. We're just going to put an underscore because we're going to ignore that parameter. This is complaining, so let's put one more space. And then we are going to move the add method. We're going to copy the signature from the actual repository. So we copy these parameters. So typically, a dummy repository will have an in-memory list. So we say bookings equals this, because we don't have a real database, but we can still store objects. And this will allow us in the test to verify that the objects are being created correctly, or to test how we retrieve them and how we filter them, or how we update or delete them. So we say booking equals booking. We import the business object, not the database object. We import that. We say restaurant equals restaurant. The date time is the date time, and the party size is the party size. We add the booking to this. We are also going to assign the ID. So booking ID equals 1, and we return the booking. This is the business object, so this is exactly what the API is expecting. Now we pass a new registry here, so we say repositories registry is repositories registry. We import the class, and we say bookings repo is the dummy bookings repo. All right, so that's all good. Let's test now the code without the database URL, and it now passes. It passes because the code is now using our dummy bookings repository. It is using mock for the database session. The reason is because we don't really care what the database session is here. This repository is ignoring that. So we fully parameterize the way data is accessed in our API. This is a very simple example, but you can imagine in more complex applications, this is extremely useful to be able to fully have control of how data is accessed during the test. And this is as opposed to having large amounts of fixtures data that has to be loaded into the database or accessed in some other way. I once had a chance to work with an application that was handling large amounts of data. It was retrieving up to 1 million records from the database, and you can imagine during the tests, this was extremely slow. Running a few simple tests would take a very long time. By using the repository, we were able to get rid of the database during the test, so we didn't have to wait anymore for these long queries that would take up to 1 minute to run in the database. We were able to inject nice and simple list of records in the code with the help of dummy repositories. One more thing to say is repository is a pattern with a long history, and it was very well described by Eric Evans in his domain-driven design book, this one over here, and it was very well described also by Martin Fowler in Patterns of Enterprise Application Architecture. I highly recommend you to check out those books. They are some of the best books in software, and they will give you a lot more insight into how the repository pattern works and what are the use cases and when you will get more benefit from using it. Hopefully this video has been useful for you. It has taught you something new, and hopefully you're excited about this pattern and you get some benefit out of applying it into your daily job. One thing I would say is this is a very simple pattern, but sometimes it takes a little bit of practice to get it right. So if you want to practice a little bit with the pattern and there's something you don't understand or you run into problems, feel free to ping me in Twitter, LinkedIn, or raise an issue in the GitHub repo for this tutorial, this one over here. Again, the link to this repo is in the description of the video. I'm going to put my contact details also there if you want to reach out to me. Before finalizing, I would like to mention that I'm the author of a book titled Microservice APIs. And in chapter 7 of this book, I go in depth into how this pattern is used to decouple the business layer from the data access layer. If you're interested in the book, I'm going to link in the description of the video a URL where you can download a free sample of 2 chapters. One of them is chapter 7, in which I actually describe this repository pattern, and I will put also a discount code which you can use to obtain a 40% discount from the price. If you like this video and you found it useful and you would like me to continue producing this kind of content, please like the video, make comments, share it with your networks, and subscribe to the channel. Thanks for watching and see you soon.